Hi everyone, welcome to GTech Techno Solution Private Limited. Now we are going to discuss about ratios. So we shall proceed with that. So in this chapter we are going to deal about the definition of ratio, units in ratio, followed by the equivalent ratio along with its examples, and then we are going to deal about the lowest form of ratios with its examples. So if we see about the ratios, the definition of a ratio is, it's considered to be the comparison between the quantities that can be made by using division, and also we can say it by verifying how many times one quantity is into the another quantity. So this methodology is said to be called as comparison of ratio. Ratio can be denoted as the symbol and the denotation. So this is the ratio. You can find the symbol of ratio in between the two terms. If we move to the next concept, it is all about the units in ratio. In terms of the ratio units, we need to calculate the ratio. That is, to calculate the ratio, the two quantities have to be measured using the same unit. Other than that, if not, they should be converted to the same unit before ratio is taken into consideration. And also the same ratio can occur in different situations. So this is one such example for representing the units in ratio. We have 5 hours to travel 360 kilometers is about dash kilometer per hour. We need to find out the value. So we got the values over here, kilometers, which is in terms of the hours. On solving this, we'll be getting the value as 72 kilometer per hour. Followed by, if we see about the ratios, using its order in which the quantities are taken into consideration to express the ratio is considered to be one such most important point which needs to be taken up in mind. We have an examples over here. The first one is all about 1:2 is different from 2:1. Apart from that, a ratio can be treated as a fraction. So if you see over here, 1:2 is represented as 1 divided by 2. This is nothing but the conversion of how the ratio is getting to be treated as a fraction. So this is what we have been having an example over here, 1:2 written as 1 divided by 2. Now let's talk about the equivalent ratios. The term equivalent ratio is emphasizing about the value of equivalency in ratio. If we see about this one, two ratios are said to be equivalent if the fractions corresponding to them are equal or else equivalent. To calculate the equivalent ratio, we need to first convert the ratio into a fraction, and then we need to multiply, or else we can divide the numerator and denominator of the fraction by the same number. If we see this one, we have an examples. We got to see the first one, that is 3:4 is equivalent to 12:16, and the next one is 4:9 is equivalent to 16:36. As we have seen before, in order to deal with these kinds of equivalent ratios, we have the conversion as the first step. So 3:4 is represented as 3 divided by 4. Followed by 12:16 is represented as 12 divided by 16. Since we have converted the ratio into a fractional term, then we need to multiply or divide the numerator and denominator of the fraction by the same number. So on multiplying, we will be getting 3 into 16 as 48 and 4 into 12 as 48. Same way, if we do the second one, 4 is to 9 is there, which has been represented as 4 divided by 9, and 16 is to 36 can be represented as 16 divided by 32. On multiplying, 4 into 32 will be getting 128, and 16 into 9 will be getting the value of 144. So this is all about how the equivalent ratios are to be identified and solved. You can find the other example for the equivalent ratio. Since the term which we have over here is 4 is to 5, which is equivalent to 8 is to 10 or 12 is to 15 and so on. So the logic behind this is very simple. If you see over here we have an example, that is 4 is to 5 is equivalent to 8 is to 10 or 12 is to 15. So if you see over here 4 is to 5, which is equivalent to 8 is to 10 and 12 is to 15. The reason is that if we multiply this 4 into 2 with the same 2 in the 5, we will be getting 8 and 10. Since it has the divisibility of 2 as a common term, we can have the equivalency for 4 is to 5, which is equals to 8 is to 10. If you see in terms of 12 is to 15, the term 4 is over here and the term 5 is over here. On both the terms, if we multiply 3, we will be getting 4 into 3 as 12, the first term, and 5 into 3 as 15, that is the second term. So now we prove that 4 is to 5 is equivalent to 8 is to 10 or else 12 is to 15. Now we shall move to the next concept called as lowest form of ratio. A ratio can be expressed in its lowest form, which is expressed over here with an example. So if we see this one, we have the ratio 15 is to 65 in its lowest form, that can be written as, the first step we have been rewriting it as fraction. And then comes, we are simplifying this 15 as 5 into 3 and we are simplifying the 65 as 13 into 5. Since we have 5 in the numerator part and 5 in the denominator part, it is getting to be cancelled in the next step. Since 3 and 13 cannot be getting to be cancelled, so we have simply mentioned 3 in the numerator part and 13 in the denominator part. Now we got the answer in fraction, which we can convert it in terms of the ratio. So 3 is to 13 is the ratio. So we have solved this 15 is to 65 in its lowest form, that can be written as 3 is to 13. Hope you got an idea about the fraction in terms of ratios. Thank you for watching this from GTech.